Hey everybody, this is Larry, this is me coming Q3 of the weekly contest 420, minimum division operations to make array non-decreasing. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one is, the key thing to note is that, one is that we have to think about the operations we're doing, right? The operation that we're doing is to make things from one number to go smaller. And because you can only make things smaller in one dimension in that order, it means that if you look at it backwards, then it has to go like there's only one. If you are able to find an ordering, and for this particular problem, the ordering is going from the back to the front. That means that there's only one operation that you can do. For example, what I mean is that, even though this is -1, let's look at this one, right? Example 2. If you have 7, 7, 6, 6, well, you can't make it, you know that you have to make 7 smaller than 6, or the index of 7 smaller than the index of 6. Well, you can't make 6 bigger, and so you have to make 7 smaller. How do you make it smaller? Well, you do one operation, and, well, this operation, you have no choice, as in there's no decision inside that operation. You just the only decision is either you make it or not. And because 6 is less than 7, you have to make it. Of course, in this case, you can't actually, because there's no prime divisor under 7, but that's basically the idea behind a greedy solution going backwards. And then now, the next part, of course, is to figure out how to get the greatest proper divisor. There are a couple of ways to do it. The way that I did it during the contest, or the virtual contest, is by using the CIF, which I'll put up here. As you can see, the code is actually very short and tight, but you can Google the CIF of those. I always spell his name wrong. Okay, fine. I'm uneducated today. But the idea here is, and the CIF there's a prime CIF, and the way that we have the CIF is related to the prime CIF, but it is not the prime CIF, but it is the idea that, okay, well, for 1, we do everything, and then for the number 2, we do every second thing, and then we do every third thing, and then we do every fourth thing, right? And that's really the idea behind this. And the way that we get the biggest divisor here from this particular method is because we always update it to I, but I always gets increasingly bigger, right? That means that when I is that means that when we do this update, I will be the biggest number that J will have ever seen. And that's really it. And we start with I being just 2 times I, and then we just keep on incrementing, right? So that's basically how you do it. I did get a wrong answer on this problem because I actually, for some reason, I kind of paused in my head as that you need to divide it by a prime number. It was clearly wrong, but I misread it. I think the other thing I would also say is that if the number itself is a prime number, then it cannot go any lower, and if it cannot go lower, then that means that if it's higher than the number to the right, then you have to return -1. So that's pretty much the two concepts I have. And this comment here is actually what I was talking to myself about two things as a reminder to talk in this video, actually, is that one, I naturally wrote the prime CIF because it's just, I don't know, I've done it a million times, and this is what happens sometimes with bad pattern matching, right? Is that you focus on memorizing patterns, you might not think about what you're trying to solve, and therefore you make a mistake here because you're just copy and pasting. I mean, I did it in my head, so it's not like but same idea. And then the other thing that goes with that, of course, is just practice. I don't practice enough, so I'm just very rusty on problems like this. So here we look at it backwards, right? So if an index I is greater to the index to the right, then we have to make num sub I smaller. And if this is not prime, then we can do an operation. And an operation, we just get the biggest divisor, which as we mentioned, get the CIF, calculate here. If after doing all this, if this is still greater than it, which means that it's prime, then we return -1 because it's just not possible. Otherwise, then now you go to the next index and do it again. What is the complexity here, right? It's a little bit tricky. This is actually mx, where let's just say m is the max number, which is 10 to the 6. It's going to be m log m. Not going to go over the hows and the y's, and there's a tighter bound, I understand, but you can just think of it as 1 plus, or more precisely, m plus m over 2 plus m over 3 plus m over 4, and it's roughly m log n. Or m, sorry. Here, this is obviously an O of n loop, but we have this while loop in the middle. How does that go? Well, the thing is that in the worst case, and I don't even think this is right, but you could be very sloppy with this, right? Because you're just trying to prove an upper bound. And with 10 to the 6 is a million, which is 2 to the 20-ish, right? That means that at worst, and there is a much easier, because you can't, because yeah, you can find a bigger proper divisor, but even if you just divide it by 2 every time, this will be at least, you'll divide by at least 2 every time. That means that this loop is at most 20. Also logarithmic in the number of bits, which is m, right? So yeah, this is going to be O times log m in that sense, and that's how you analyze this part. And that's all I have for this one. Let me know what you think. Thanks for watching. I need to get some sleep. You can watch me solve it live during the contest next. If I time out, I might, okay. I actually wasn't sure. That's why I had to like pause. That one actually should have gone faster. But okay. 3,000 is such a weird bound to pick for that reason though. Anyway, any positive focus. Any positive divisor of an x that is strictly less than x. Okay. You're allowed to perform where each operation select one element nums and greatest proper divisor. Return the minimum number of operations to make the non-decreasing. 10 to the 6. So we're doing the CIF already. Non-decreasing is monotonically increasing kind of thing. Okay. I mean, you just do it from right to left. I think greedy is fine. You just have to, the trick is sifting that through, right? Because, yeah, in a greedy way, it doesn't, there's no other thing to do. Okay, so it's 1 is no good, 2 is no good. I guess prime numbers are divide, right? So yeah, prime numbers are no good. Every other numbers are good. You have to find the greatest whatever thing. Alright, okay. So then now while, yeah, okay. And is prime of, if this is not S prime, then num sub I, I don't know. Okay, right, and then now if num sub I is still greater than, then we return -1, otherwise, well, we're just good. Oh, wait, what do we have to do? Minimum number of operations. Yeah, there's no choice. Now I just have to fill out the rest. Okay. Yeah, okay. Have to do this stupid pre-processing. I guess it's not worth. Oops. It's not worth trying without it. 0, 1, 2, right? So then for 2. Yeah, okay. No, you're fine. And nope. What are you doing? That's already priced in. This is a prime. Then is that true? That's true for prime, but I guess maybe it's actually it's not true for what I needed to do. Out of bound. Yeah, because it's not supposed to be. Yeah, okay. 0 milliseconds, is that right? Alright. What is even a big number to test? Alright, I'm a little bit lazy. Let's YOLO. Oh, oof. Did I do the math wrong? Maybe I did the math wrong. Why is that? What's 105? $105 is what? 3 times 35? 375? 357? Maybe I should have double checked it. 105. 357 now is 35. What is it doing? What is it doing? Why? Oh, okay, so it's doing it right. Maybe. Why? What? Why am I so bad at this? This should be done. This is a silly mistake somewhere. Huh? How is this 15? Oh, no. This is, okay, so count 1. Then 15, 11. So isn't this 2? Oh, I put 2, but it's expected as 1. Oh, divisor, not the prime. Do I not do that? Oh, I only check this for if it's prime. Oh, you silly Larry. Silly. Okay. Yeah, whoops. Why would I only do it? Yeah, okay. Okay, well. Whoops. How am I doing? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. My explanations are pretty good. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.